Hello everyone, this video is about my program Portal App. It is a program where you can play with interactive visualizations that I made for my video with gravity in portals. And also this is a program where I created all my animations for this video. I think it is a very powerful program where you can create interactive visualizations, just regular visualizations, and also physical simulations. And this is why I create this video to showcase this program and the component system that I made specifically for it. So currently this program only available for my patrons on my Patreon, but I have plans to open source all of this in the future and make it widely available, and also not about portals, but about just visualizations and everything. So this video will be split in 3 parts. In the first part, I will show you what you can do in this program just as a user, just how you can play with it, what interesting things that you can do in it. In the second part, I will show how you can create your own scenes, and I will talk about my component system that I invented specifically for this program, which I think is pretty powerful. And in the third part, I will talk about future plans and how will I extend features of this program to be more useful for everyone. So let's start. When you open this program, this is the first thing that you see. You have some windows, menu, and this canvas. You can move this canvas with the mouse, you can zoom in, zoom out, and you can see that there is these buttons that you can move around, move something, and move this thing. But when you move it like this, the cube disappears. Why is that? Well, it's because we haven't started the time. So currently time on a pause, and we can start it, and we see that our cube starting with the initial velocity. And it is teleported through portals. So because this is a portal app, you play with portals, and you can do things like this or like this, or you can move this wall, you can cut the object and everything like that. So let me show you interesting features that we have here. So we have this interface where you can change coordinates like this or like this, or rotate the portal or scale it. Yeah, we can scale the portal and do scaling portals, physics with scaling portals, although it's currently working incorrectly, let's say like that. You can change this thing. For example, you can set it to be very small, and you can easily now cut the object. But if you increase the size of these edge walls, then your object almost never gonna be cut because they are too big. Or you can change the shape of a portal so that it is different. And a lot of things about this soft body, like its initial velocity. Let's make it 0 so that it doesn't fly. And you can see we can use moving portals to add momentum to the object. Then we have another interesting thing is this. It's a speed arrow. Let me pause this. Current speed of the object is visualized with this arrow, and we can make speed something like that. No? Oh yes, we have very slow speed and very slow time, and when we move the wall, it gives a lot of momentum to the object, and this is why this speed arrow becomes very big. And when we use regular time speed, we see that the object moves very fast. So there is a lot of things that you can play with, and this is just the first scene. Oh, also, there is this collapsing header called animations. and you can see a lot of interesting animations. For example, this animation is depicts one of the portal properties, speedy thing goes in, speedy thing goes out. Or another property, when portal moves, it also make the object move that it consumed. And something like that, but this is for patrons. There is very interesting animations. Yes, like this. Okay, the next scene, interesting that we can play with. We can load it from this menu. It's called up and down portals. And this is a scene where I calculate gravity in real time. So we can start the time and the object is affected by the gravity that portals have bent here. Overall, gravity is located, points downward, like here, but near the portals, it is changed. And we can move portals and gravity recalculates in real time. Actually, it's very cool, and it's a finite element method, and there is not a lot of programs where you can calculate finite element method in real time, actually. And also there is these streamlines that show direction of a gravity, which is also very nice. It took a lot of time to program, actually, this thing, but it is very useful. I could not make video without these lines. So what else there interesting? Oh, I also put a lot of controls that I changed in my video so that you can play with it and you can verify all my animations yourself. The next interesting thing that I want to show you is not this scene. Two planets. Yes, this scene. It is a scene where we have two planets that create gravity. And you can see because this planet is small, it doesn't attract the object. And the big planet attracts the object. But we can change the planet radius here and the behavior changes. For example, like this. Oh no. And one thing I wanted to show you in particular is, for example, let's make this something, no, not like that, 0.05, and put this in the center of other sphere. So currently we have two planets. Here, two mass sources. And we see that we can change their density. We can make it bigger or smaller, and also we can make it negative. So what happens here when we make this density negative? Positive density of 22 and negative density of 22 sums up here, and we have zero mass at this location. But we have positive mass at this location. So this, it simulates, how it's called, a shell. So the mass distributed in this shell, and it calculates the gravity of this shell, how it looks. And it's actually a very interesting thing, because inside the shell, the gravity is zero, as we can see with this color. And streamlines are buggy here, but outside it works as a usual planet. So this finite element method is very interesting in terms that you can calculate gravity of complex objects. I think everyone programmed their own gravity simulation with point masses and Newton law. But this thing allow you to integrate over the whole distribution of mass of this object, and it's very interesting. And also you see that we have positive density and negative density, and if we make them have the same radius and enable streamlines, you see that it looks like a magnet. So some of you know that Poisson's equation not only simulate the gravity, but also something related to electrical charge or something like this. And you can also treat this as a negative charge and this as a positive charge. And this how it will behave. And the consequence of that is that you can play with this as with positive and negative charges, like electromagnetism calculation. And the last thing that I want to show you is that all the animations that I have in my video, they are located here. You can see them. And if you want, you can edit the scene and see how I created all these animations. And for example, I can show you this scene, and there is a lot of other animations. For example, this animation, I like it a lot because it's just cool zoom. Or this, or this, or this. So all the animations that I made, or the static pictures, they are inside this program. And now we are approaching video section about how I created all these animations and all these scenes. So let's start. We have this button called Edit Scene. And when we open it, we can see all the internals of a scene. So what I have here, basically my program is a program where you can edit different components. You can link them together, or it's like, node graphs. It's like a node graph, but without graph part, without graph visualization. You have a lot of nodes here, components. They can reference each other, but they reference each other by name, not using arrows in this graph interface like in DaVinci Resolve Fusion or like in Graphite. You just reference to everything by name. So in this scene, it have a lot of components that it consists of. And to understand these components and how they work, let's create a empty scene. So to do that, we go to load, technical and none, and we create empty scene. If we allow scene editing, we see that it's actually not empty, but it has all the essential components by default. So you see that special components are represented with a green name. And if you create regular component, it will be just it will have white name. And also I documented all special components and their properties in documentation here. So let's create component float. So in this component you can change its value, and you see that value changes. Just regular simple component that you probably have in every node graph or something like this. Let's make it so we have type of this component, name, let's call it sum, and we have a kind, subtype, let's say, call it subtype of this component. And we can select a lot of things here. For example, progress is just this interface to change the value from 0 to 1, and you can see how value changes. Or angle, where you can change angle in degrees here and see the radians value here. And a lot of other things. And for example, we have sum of floats, but we see currently there is this strange interface. Let's press these buttons right now, and we sum two values. So let's create other components that will represent other values. Let's call it A and B. And let's make them also floats, and write their names A and B. Oh yeah, failed to get cache, yes. Sometimes we need to press this button, reset cache, to recalculate everything because I have some bugs that I will fix in the future. So right now we have A component and B component. Let's set its value to 1 and this to 3. And now we see that this sum component uses these other components and calculates their sum. And when we change this value, it automatically recalculates and shows us the new value. But what is the difference between my component system and other component systems? In other component systems, I think you can create different components and only reference them by name. But in my component system, you can create inline components. And it is controlled by this button. Pin button, it creates inline component that you can change in this place. So it's like anonymous components. You don't need to create a new component and give it a name and reference it by name and have gazillion of components with gazillions of names. You can do it all inline if your calculations needs it. And there's not only sum. Oh no, let me show you the possibilities. You can make these inline components recursive. You can create a lot of sums and sum a lot of values. So it's all recursive. The other interesting thing that, for example, let's not create sum, but vec length. So we have component of type float2, which is basically a vector. And you see that it has 2 values. And we can calculate its length and sum it with this value. And we see that we have some result. Or we can create vec length and this vector will be transform position, which uses some matrix and position, applies this matrix to this position and returns the vector. And then we calculate its length and then we sum it with this value. And for example, we can do it like this, then rotate it. Oh, not let's not use vec length, but x value from that vector. Yes, and then we do that. And let's put 0 here. We see that this matrix, it rotates everything around the origin, and our vector that it rotates is just 1, 0. And when we rotate this matrix, we see that this value should be sinus or cosinus, I don't know. Okay, but how can we use that to create interactive scenes? So let's create something that can be visualized. For example, let's create a wall. So we created a wall and we don't see it anywhere. Where is it? The thing is that I use components to visualize everything on the screen. So let's call this wall just a wall. And we have this component called draw. And draw is a collection. And when we put something in this collection, it will be drawn on the screen. So let's add this. Oh, and we can see we have our wall. Next, we can change some properties of this wall. For example, its scale. Or also you can see that this wall has uses two subcomponents, matrix and color. And also it has different types. For example, rectangle or circle. And you can move this matrix or use it from other components, and you can change the color of this wall and something like that. But we want to move this wall. So how can we do that? To do that, we need to create different component. Let's call it wall pose. And then we need to use this vector in this matrix to set the position of this wall. So there is a property for that called parametric matrix, and this parametric matrix accepts offset, rotation, and scale, and you can change these properties through other components to change behavior of that matrix. So we can change this to be a wall pose, and now when we change this value, wall pose, our wall will move. But how can we move it with the mouse? There is other special component for that called screen points. It's also a collection, and when we put this wall pose, it will create this button, this point that we can move on the screen. Let's create another wall. Let's call it wall 2, so that we see something like background. And let's make it green and rect, and like this, and let's put it into the drawing. Oh, it's very small. Oh yeah, I see. Why is that? Oh, also you can see that this wall collection controls what is drawn first. So when we change the order, we can change what is drawn above or below what. So now we can move this wall, we can move the camera, and oh, what I also wanted to show you is that in collection you can create, how is it called? If thing. So let's create component called enable wall 1. It is gonna be bool. Put it here. Then we have to create another collection called walls 1, and it is collection. Let's add here wall 2, empty. I see. So what have I done? Now we have this conditional element of a collection. If this component is true, then it will add this collection to this collection, and otherwise it will add this collection, which is just an empty collection. And as you can see, currently I have this value to be false, but when I press it, something is broken. Or reset cache again, yes. So we can control which things we draw on the screen and which are not by just the bool component. And the beautiful thing is that you can change these values in some animations and you can easily control your scene. Yes, and we are approaching interesting thing about animations. So we have all our components that define our scene, our visualization, and something like that. And how can we do an animation with this? There is this thing called patches. So you can create a patch to all this component that replaces other components and allows you to create animations or user interfaces. So let's create a patch. Let's call it anim dot just anim. Just move a circle. And we can select current patch here. It's either dev or the patch that we created. So on this patch we can, how we can animate this? Oh, I have an idea. Let's create an animation that this circle moves from this position to this position and call it a day. Yes, how do we do that? To do that, we need our animation to somehow know the time of this animation. And for that, we have special component called time. It is just a float. it returns a float that later we can use in different calculations. So we can create a new component called float, just to show you what is it. And from time. And when we start the time and pause it, 2 seconds has passed, and we see that this float value have 2 seconds, value of 2. And we can use that to calculate these coordinates. So how can we do that? Let's create let's create 2 points that we want to interpolate with. Let's call it P1, it will be float 2, then P2, it will be float 2, then we have to change our wall pose according to these 2 points. So let's create wall pose, which will be float 2, and subtitle of this float 2 will be lerp, which is linear interpolation. So we can specify 2 components here, P1, P2, and then we can specify the t value. Let me show you how this looks. So currently this is 0, 0, but if we change this to be something like this, you see that we can move this circle with this value. But we don't see, I think you want to control these points on a screen, not through this interface. So to do that, we just need to create screen points, which is collection, then add P1, P2, and now we should see, why we don't see them? This is strange. So I have found a bug why we don't see these screen points. It is because I disabled them when we are in the animation mode. So let's just rename this thing not to be anim, but just move circle and select it. And now we can move these points. So we want this circle to move from this point to this point. And as we can see, it is very convenient to do animations. So it just changes like this. Yes, and the next thing that, let me move it here. The next thing is that we want to create an animation from this. So for animations, we have to use 2 components. First component is time. It specifies time of our animation, and other component is render to time. This component specifies the duration of our animation. So let's write render to time to be like 4. Then we need our wall position to be changed. Let's just create from time and time. Yes, and let's start the time. And the first thing that we see is that when time reaches value above that is bigger than 1, it goes in strange direction. So we need to limit it to different values. So how can we do that? We can use max, or we can use division. First we put from time, and then we divide to our render to time component. So what happens when we start the time? Oh yeah, we also need to count to render to time. I need to change this scene. So what happens? This animation, when it reaches a value that is bigger than render to time, it automatically, I don't know this English word, I'm sorry, you understand me. You see, 0, 1, 2, 3, 0, 1, 2, 3. So, what is the problem about this animation? It looks very linear. And if you put this animation into your video, it will be very abrupt. So to make it better, there is this thing called easing. So how can we do that? We need to change this div to easing. And this easing should be in out. Then this t value, you can see how smoothly it starts and smoothly finishes. So then we put div, then from time, and then render to time. And when you play this animation, you see how smooth it is. So the next thing, let's change this name to be anim.moveCircle. And what happens is that when we press this button and then Control Scene, we have animations. And you see that we can play this animation, and later we can render this animation to some video file. And let me show you how I use these files. So when I render my animations, I just put them in DaVinci Resolve, and I just do all the usual editing stuff. So my program is not a replacement for editing software, it's just a replacement for animation generation, when animations are very simple like this. And another thing that I haven't showed is how can you animate the camera. So there is this special variable called camera. It is the main camera that can be changed through mouse movement, or you can press this button and change this value through this interface. So how can we animate the camera? To do that, we need to create a camera here, and then we need to select it to be camera, and we have different camera options. For example, we have simple camera, which is just this value, or we can change it from screen and change its value, or it can be parametric, so we can put offset component to control this camera, or it can be interpolation between two cameras. So, and it's very interesting. For example, let's set, it doesn't work. Let's create camera cam A and cam B. And let's put these cameras into this interpolation. And let's make it progress. So to control this camera, we need to press this checkbox, and now we can control this camera. Let's let it be like this. Then we unpress that checkbox and press that checkbox in other camera. And let it be like this. Okay, so we have two cameras. And now we want to interpolate between them. And it is already working. But as you can see, it's also linear. So we need to add easing. And now it changes smoothly. And now we need to also change this to use time. No. Let's it be division from time, then render to time, and there we have it. Let's start the time, and you can see how this animation looks. So this is very convenient way to create animations, in my opinion, because you see everything immediately, every result you see immediately, every value that you change, you see immediate result about how it affects the animation and everything like that. So this is why I created this program to do all my animations. And let's get to the next part where I show you different side of this component system. So let's create in the finite element method thing. It is called just fem. So when we create this fem, it requires us to set a lot of variables. So we have force recalc. It's let's just do it like this. Once button, yes, like this. It's just a thing that because this is very expensive to calculate, we just have a separate button when we disable automatic recalculation, so that we can recalculate it by click of this button. The next thing is portals collection, mass object collection, and point sources collection. Let's set this to empty and this to empty. Oh, and also you can see that my component system have error messages. For example, let's create portals. It should be collection. Let's add portal here. And let's add portal component. Yes, like this. And let's put portals here. Oh, recalc. And failed to get cache. Yes, reset cache. I probably need to fix that bug. Oh, there you have it. So we have finite element method, but we can put this into draw. It won't draw the finite element method. Why is that? Because this component is about calculation of the finite element method and not about its drawing. As you can see, this calculation of this component took us 6 milliseconds. So it's very expensive. And to visualize this component, we need to add another component called fem drawing, which is this. And here we need to specify only finite element method. And then add this component to the drawing. Now we can see our finite element method. Let's see what we can do with it. First, we can set boundary conditions. Currently, we have boundary conditions for potential to equal 0 at the edges. But we can create it to be directional gravity, something like this, and we will have boundary conditions to set that this square have so we have globally gravity that points downward, and we have portals here, of course. So we also need to visualize portals, so let's put our portals collection here. Yes, now we can see the portals, but let's make them bigger, have more thickness. Oh no, that's too big. And change this color to this, and we can see our portals. And let's put this portal structure into screen points so that we control these matrices. It automatically goes through every subcomponent of the thing that we put there, and we can control this position. And you can see that finite element method automatically recalculates when we change the portals. And interesting thing about my component system is that it have cache. And cache, it means that every component value is cached. And this cache is recalculated only when we change dependencies of that component. So, what does this mean? When we move this circle, finite element method isn't recalculated because this circle does not affect the finite element method. But when we move the portal, you can see that timings on the finite element method changes. It is because it is recalculated every time. And it changes because finite element method depends on portals collection, and portals collection depends on the portal, and portal has this matrix that changes inside it. So this is a very powerful feature of my component system, and one of the reasons why I designed it, because I wanted to have the ability to change something about soft body object without recalculating finite element method, or change something in finite element method without recalculating the soft body, so that they can interact in a meaningful way. And of course, because FEM is very expensive to calculate. It took us 20 milliseconds, but if we make these triangles smaller, for example, like this, it will take, you see, how much time it takes to calculate this finite element method. And this is also very useful for drawing. For example, when we change something that is no, let me show you differently. So for example, we have this FEM drawing component and we can draw triangles. And when we draw these triangles, FEM isn't recalculated. Its value doesn't change. So it's very convenient to change different visualization options without needing to change to recalculate this. Because in my first implementation, when I implemented this, I had all this in one component, and when I changed this value, it triggered all the FEM to be recalculated. And this is why I separated them to be in two components. And the next interesting thing is that all these settings, they are uses other components. For example, draw triangles uses bool component, and we can move this value into some variable. For example, we have this enable wall. Let's say that we want to show triangles only when wall is enabled. So you can parameterize how it is drawn. Or another interesting thing is that you see that we have triangle thickness. So this triangle thickness is set in the world coordinates, world unit, world length, and when we zoom, we see that this length doesn't change and the triangle edges are very big. But we want this to behave in such a way that when we zoom in, this thickness changes according to our zoom. How can we do that? You see, we have a camera component, which is our current camera. So we can utilize that. We have matrix component, and we can obtain matrix from camera. And when we write our camera, You see that when we move this camera, its raw value changes or calculated value changes. We can use that, for example, to transform vector with this matrix. So let's call it cam matrix, then create something like this, and let it be float, which will be length of a vector, which is transform direction of a matrix that is from camera, and it should be like this. Oh yes, you can see that when we change the zoom, this value changes, but when we move the camera, this value doesn't change. And we can utilize that value to change the triangle thickness. So how can we do that? We need to multiply it. Let's press this button, then move, then this and this. No, this is very big. Let's make it like this. And now you see that this value is multiplied to our cam length. And when we zoom in, you see that this triangle thickness is automatically changed to have constant size in pixels on screen. And this is very powerful side of my component system, that you can use any value to calculate any other value. And you can use current camera to create such a thing. If you created this visualization from scratch, you have to write some hacky code to do this kind of feature, that when you zoom in, your scale thickness of a triangle edge changes according to your camera. And there is a lot of places to introduce bugs to this. But with this component system, there is no place to bug, or you don't need to write Rust code to change this. So I'm very proud of this feature. And the last thing, that you can create physics simulations based on this component system. So let's create a component called soft body, which is soft body object. So it accepts time, then portals, then walls, and also fem. Walls 1, yes. Let's disable triangles, and let's visualize this soft body. It is located here. Let's move it to different position. Screen points, soft body, and let's start the time. What happens? Oh, it destroys. Yeah, I see. It is destroyed because it is located right inside the wall. So we need to move this wall, green wall. This one. Yes, wall 2. Let's put it in screen points. Then move this wall to be here. Then move our soft body. Oh, now it works. Yes, but somewhat it started to move in somewhere. Why is that? Okay, never mind. So you can see that we can create soft body and it is calculated when we start the time. How does this work? So this soft body is it is recalculated every time step. So when we start time, it is recalculated every time because it depends on the time which is changing when the time changes. And this soft body, it accepts the previous value of its internals, and every time it just calculates the next timestamp of this soft body, and then we can visualize it. It's hard to explain without showing the code, and code is very messy right now. So I hope you get the idea that you can also create physical simulations inside this component system using time and other components, which is very cool, I think. Yes, another thing that I wanted to show you is that we can create very strange portals with scripting language. So you can see that this portal is flat, but we can select different options. For example, it can be Rhai, which is currently doesn't work. Yes, we have error in finite element method, failed to add portal. Rhai is not supported. Yes. Or it can be semicircle, where we can change this semicircle value. Or it can be circle, or a wormhole, which is a topic for some of the next video. And it can be from program, and it can use Rhai program or Rhai program. So let me save the scene, export pretty. Also, scenes are serialized in this structure. You can easily change something in your scene through this text file. So let me save this scene. And let me show you how we can create different portals using this program. So I have a scene called technical portal program example. And you can see here that we created a portal in the shape of a sinus curve. And we can change different parameters. For example, amount of segments, start and end value, Rhai position, and position and orientation of the portals. So how is this calculated? We have portal component, which is calculated as a portal from program and program. Then what is this program? It is this. This program is written in Rhai language, which is, let me show you, which is this language, embedded scripting language for Rust. And I just use it because it was very easy to use. I don't know about different languages. So I wrote a program in this language, which is basically have the main thing is this lambda, where we have this sinus value that changes from x. For example, we can make it to be sin of sin and sin of sin of sin, and how it looks. It looks not very interesting. Let's multiply it by, let's divide it by x. Now it looks more interesting. Something like that. And we can change it to be anything, actually. We can write a program that creates any type of portal that you can think of that consists of segments. For example, there's this scene called attempt to create pocket dimension. So our community member Frisk256 created this Desmos scene where he imagined a set of infinite portals that enter each other in such a way, and this should create some sort of pocket dimension without scaling portals, something like that. And I visualized this scene in my program, and this is calculated, of course, through Rhai program, which is which is very big. I didn't write all this code. I just asked ChatGPT to write this code from this Desmos formulas. So sorry for being lazy. And it is pretty powerful to change every component, not only through my component language, but also through this scripting language. And the last thing that I want to show you is how it looks in the Rust code. So this is how it looks. First, we have a type called inline or named, which is either inline component or named component that we can reference by name. It is a thing behind this pin button. Where is it? Behind this pin button, we can specify component to be inline or to reference other component by its name. So this inline or named component is just a useful type. Then what is a bool component? You remember that bool component, let's use this, is just a lot of values. For example, variance, not of true is false, and of two bools, and something like that. And this bool component is just a enum, where we can control these values. For example, simple is just a bool value. Variance is just a bool with two strings and variant type. It's just different how to visualize this in the interface. Now, not variant is inline or named bool, so it accepts different component to calculate this value. Or and it accepts two components. Or this one, less. It accepts two float components to compare them and return a bool of this comparison. So, and we have a lot of trait implementations for this enum. For example, default is just a default value that when we click in the interface, it will be initialized with this value. Then calc trait for this bool component, we specify the result value, which is just a bool, and then we calculate this value based on the type of this component. If it is a simple component, we just return the value. If it is not, then we calculate inner component using this macros, and then we just negate it. Or for end component, we just do it like this, or components like this. From usize, from float, you get the idea. And it's very, very simple code to calculate this. All the boilerplate is written somewhere else. You don't need to see that. The next trait is bool variant. It allows us to initialize component when we select different types. For example, when we select from float, it specifies what default value should it have. And here it have from float, bool from float, and uses default value of the float. Very easy. Next is the IGUI trait for bool component. And basically it just a combo box to select type of this enum, and then we match this enum and draw different interfaces based on this. For example, for simple value is just a checkbox. For end with two values is just sub interface of inline or named interface. So it's very easy to write. The next trait is user IGUI for this bool component, which is just user interface that you see here. Oh, I completely forgot to show you how user interface is created. All right, I will return to that. And also a documentation for bool. So I have automatically generated documentation that you can see here. It is generated for every component, but for now I've written it only for bool component. Sorry, I'm lazy. Not lazy, I didn't have the time to write all this documentation because this video took a lot of time to produce. I mean video about gravity in portals. And the beautiful thing about this is that it is automatically generated, and when I add a new enum variant, I never miss this documentation, because in this code it will have a compilation error if I forget to add different field here. So this is the code. It's very simple, very easy to create your own components. And the last thing that I wanted to show you is user interface. So let's return to our scene, import. Why do we have errors? Oh, yes, because this. Now, how do we add user interface? There's this variable called interface, and you can open control scene and see that currently it is a label that says user interface, and you can see it in this window that actually says user interface. You can change it and it will be updated here. So, for example, let's say that we want to control this position in the user interface. For that, we have this subtype called named, and then we put wall pose here. And we have this wall position, and we can change it, and we can change its name. And there is a lot of things like horizontal, vertical arrangement, separator, collapsing header to do a lot of things. And there is also conditional interface. For example, you can have yes, we have this variable enable wall, and when it is true, we can control let's say wall 2. Let's control something, wall pose. And when it is not enabled, it's just empty. So when we change this variable, you see that the user interface also changes, and we can create let's make it vertical, then named then conditional interface, enable wall, then named, then empty. So we have created conditional user interface, and all the things that I created in other scenes, for example, all this interface is created through this variable, and I can show it to you here. So all these things, these are just one big component, which is this. So it's also very convenient to create scenes that will be controlled by users through this interface component. And that's all for the how to create scenes in my program and about my component system. And the next part will be about my future plans about this program. So about the future plans of this program. Uh, I think this program just screams that it needs to have a shader component where I can write shaders in shading language, and I can pass matrices or vectors or floats to this shader to have the ability to interactively control how the shader draws. It's like kind of shader toy, but interactive. And this is my main goal for this program, to create my own interactive shader toy and open source it and make it very convenient for everyone to create their own interactive visualizations on shaders, because currently shader toy is, I think, very inconvenient to create different kind of interfaces to move points, to move the camera, to have different sliders or float parameters to control in the shader. So it is all controlled through code, which is very inconvenient. You have to recompile it every time, just very bad. And I have already a demo for that. Actually, my Portal Explorer, my previous program that I used to visualize all the 3D animations, it's actually already a sort of interactive shader toy. Let me show you. So this is my Portal Explorer, and let's open something very easy scene like um, Surface Portal, like this. And this scene consists of uh, just a cube and two portals. And what do we have here? Let's enable scene editing. Actually, I wrote this program back in 2021, and was very messy development. I come up with ideas and implemented them in architecture that really doesn't mm, support these ideas, and therefore this code is very bad. For example, I have this thing called uniforms, which is just basically float components, and you can change room size in this direction or room size in this direction, and it is just a float that is sent to the shader. The next thing that I have is matrices, and this is the same as a matrix component, and you can have you can multiply matrices, for example, like this, and it also has this inline idea. You can multiply matrices, like rotate them, rotate this, and you see that it rotates like this. You can multiply matrices or make parametric matrices, where every parameter is controlled by the float component. For example, room, oh no, it's broken. Room size X. Yes, and when we change room size X, it also changes this matrix. And this is the only thing that you can do here. You can make matrix to be to use float components, but not otherwise. You can't create a float component that uses matrices to calculate something. So this is really a step up. My new program is a step up in capabilities, because there you can use you can calculate float through matrices and vice versa and something like that. And then the next main thing that it has is objects. Basically, it's just a specification for the code generation. For example, this room X plus is just a flat plane that is defined by this matrix. Yes, you can see that it is controlled by this matrix, which is sent to shaders through shader uniforms, just matrix 4x4. And there's also a shader code, which just accepts current position, position on plane, and something like that, and it calls some code. And basically what the Portal Explorer does, it takes all these objects, materials, textures, and user code and generate a very, very big GLSL code. This is why it takes so much time to compile sometimes, because some scenes can get very big and it is a lot of shader code. And this program, it just creates this shader and sends all these matrices, all these uniforms to this shader through regular uniforms. And current camera is also a uniform that is controlled through this menu, and it is also sent to the shader as a matrix. And also notice interesting thing that current camera can't be controlled through matrix or through uniforms, because it's a different place in code. You can't make this camera to be parametric. So in order to make it parametric for the animations that I have to create separate interface that takes this camera from its place and interpolates it, and so on, so on. So it's very not general interface. If you want, for example, to make rendering settings to behave differently for different animations, you have to write Rust code for that. And you have to write new place. For example, let me show you how I make animations here. Oh, like, for example, this animation. This animation, you have to specify camera, and the only thing that you can do with camera is just interpolating two cameras. Then you have to specify already existing components, how you can change them, something like patch system in the Portal app. And yeah, it works like that. There is also, you have these animations that I render for my videos, but of course Portal app is much more convenient and general in that sense. So in the future, I want to rewrite my Portal Explorer to the Portal app and add a shader component and add Lambda components that I can encode, for example, these objects as a Lambda components that accepts matrices and code, and then does code generation for the shader code. And also I want to add Jinja inside this so that we can do very complex code generation in this Portal app, and so that you can create your own interfaces like this, for example, for internal components, so that it is very easy to do code generation and create new scenes. And of course, if you are some creator or you know how to program in Rust, I want this system to be easy programmable so that you can fork it and create your own physics simulation or For example, you don't want shaders, but you want CUDA, and you can do code generation inside Portal Lab and call CUDA compiler inside Portal Lab and do CUDA shaders or compute shaders from web GPU, or I don't know, you can do everything. Portal Lab, it will be called differently. Of course, not Portal Lab, it will be called maybe Opto Lab. You can write your own physics simulations or basically everything. Everything. You can do everything. It's just a very easy interface to do animations and to create scenes. And I think I want to compete with Manim and with Shader Toy, of course. I want to make my program better and more convenient. For example, when I tried to use Manim for uh, one of the animations for the future videos, I created some scene and realized that there is no way to move things around in some interactive interface because Manim can be rendered to window. It only can be rendered to be inside the video. And the only thing that you can do is you can change value in the Python code, then run this Python code, wait 30 seconds until it draws the animation, and then look at this animation and realize that you need different value, different position on the screen, different camera orientation, and something like that. And I just looked at it and said, no, I'm not gonna use Manim at all. This is no go for me. After you taste this interactive interface where you can create animations so fast, it is impossible to use code-based animation engines like Manim or SwapTube, for example. So yes, I want to create such general interface, but let's see how it goes. So if you are watched video to this point, I want to say thank you. Sorry for my very bad English and so that I sometimes, I don't know this word. Uh, I pause like this, like right now, because I don't know that much English words. So thank you for your attention and bye.